Features of a quadratic relation. Our learning goal today is to determine if an expression is a quadratic based on its features and to verify quadratics with technology. Please ensure you have the lesson printout so you can follow along with this video. Let's review from yesterday's lesson, properties of a parabola. You can pause the video, try filling it out, and then resume the video to see how you did. Pause the video now. Let's find the vertex. Remember, the vertex is the point on the graph with the least or greatest y coordinate, depending on which way the parabola opens. In this case, we can find the vertex right here. And we can know its coordinates as -3, 1. Now, let's find the optimal value. The optimal value is a way of stating the vertex. It could be a maximum or minimum depending on the opening of the parabola. In this case, we have a max value of 1, that's our y coordinate, when x equals -3. So this is just a way of stating the vertex. Is it a maximum or minimum value? Next, let's find the axis of symmetry. Remember, the axis of symmetry is a vertical line dividing the parabola into two parts, each which is a mirror image of the other. The axis of symmetry always runs through the vertex. So it'll be this vertical line right here. The way we state the axis of symmetry is with an equation. In this case, x is equal to -3. Now, let's state which way it opens. Does it open up or open down? That's right, it opens down. So you can see the opening of the parabola is over here, and it concludes at the vertex over here. What is the y-intercept of this graph? Where does the line of the parabola cross the y-axis? We can see the y-intercept right over here. So we can state it at 0, -8. And now let's find the x-intercepts, also known as the zeros. That's where the parabola crosses the x-axis. We can see those points over here and here. So we can state the x-intercepts are -4 and 0 and -2 and 0. Another way we can state the x-intercept is as follows. We can say y is 0 when x is equal to -4 or when x is equal to -2. Let's try another example. You can pause the video here to try this one on your own, and then resume the video to see if you answered everything correctly. Pause the video now. Let's find the vertex. The vertex is located at -1 and -1. Right over here. So let's write that down. -1, -1. Now let's state the optimal value. In this case, the optimal value will be a minimum because the parabola opens up. Remember, the optimal value is just a way of stating the vertex. So in this case, we can say it is a minimum value of -1 when x is equal to -1. Now, let's find the axis of symmetry. Again, remember, the axis of symmetry always passes through the vertex. we would state this as an equation of a vertical line. In this case, it will be x is equal to -1. And of course, just examining the parabola, we can tell that it opens upward. Now, let's find the y-intercept. We can see the y-intercept is right over here at the coordinate 0, 0. The x-intercept can also be found by examining the graph. We see one at -2, 0, as well as 0, 0. Another way we could state this is when y is 0 when x is equal to -2, and y is 0 when x is also equal to 0. So how can you determine if a relation is quadratic or not? Given a graph, a relation is quadratic if it is a parabola. That's the name we give to a curve that looks like this. We can also tell if a table of values is a quadratic by looking at the second differences. If the second differences are the same, then we know it's quadratic. Remember from yesterday, if the second differences are positive, the graph will open upwards. If the second differences are negative, the parabola will open downwards. We can tell if an equation is a quadratic by looking at its degree. Given as an equation, a relation is quadratic if the highest degree is 2. Now, let's verify the types and shapes of graphs based on equations using graphing technology. Let's take a look at the first equation. Y is equal to 3x. Let's go to Desmos. So this is Desmos, a very powerful graphing tool which will help us verify different types of graphs. So let's get started. So if you click Start, you'll see a little window like this, and it shows us our Cartesian plane here. And so what we can do, we're going to enter our first graph, which is y is equal to 3x, and it'll graph it for you. You can zoom in and out to take a look at the graph. Looking at this graph, we can see that it is not a parabola, but a straight line. So we would call this linear. We can label our first equation here as a linear. And this, we've seen linear equations before, like y equals mx plus b. This is an example of that. Y is equal to 3x. Let's try example 2. 3x squared plus 4. So let's plug in this equation into Desmos. The equation was y is equal to 3x squared. So to get an x squared, we're going to click this little keyboard down here, and you're going to see the a squared button. We're going to click that, and that's going to make whatever we have there a squared number. We have plus 4 to finish off the equation. And as we can see, it is a quadratic equation. It is a parabola. You can see it goes on forever. There we are. Because it formed a parabola, we know that y is equal to 3x squared plus 4 is a quadratic. Let's try our next example. Y is equal to 3 bracket x minus 5 bracket x plus 6. So here we are back in Desmos. I'm just going to clear my last graph and input my new graph, which is y is equal to 3 bracket x minus 5 close bracket x plus 6. And here we can see, we zoom out and scroll down, that indeed we do have a parabola. This one starts very deep, but you can see that it is still a parabola. We'll just zoom in there so you can see it. And there so we saw that the equation y is equal to 3x minus 5 bracket x plus 6 is actually a quadratic. As you know, if you expanded these two binomials, we would get a trinomial with a degree in the highest term of x squared. Let's try our last function. Y is equal to 3x to the power of 3. So here we are back in Desmos. Again, I'm going to clear my graph. Let's scroll back up to the top, or to the origin, to be right over here. And let me input my last equation here, which is y is equal to 3x to the power of 3. And to do our power of 3, we're going to go down here, and we're going to look for this button here, A to the B, and this lets us put in any value here. So we're going to put A to the 3. Okay, and if we take a look at our graph, you can see kind of looks like a parabola, but it's flipped open on one side. And this has a special name. This is what we call a cubic function. And as you can tell, because we have x to the power of cube, that's where the name comes from. The highest degree in this function would be a cube. So this one here is a cubic function. So from Desmos, we saw that this equation here, 3x to the power of 3, is not a quadratic, but it's given a special name called the cubic function. This is a cubic function. So now that we had some practice verifying which equations were quadratic and which weren't, let's try classifying some here. So let's determine which of the following is a quadratic relation. We can see here in our first example, the highest degree in the terms is an x squared. So we know this is going to be a quadratic. Let's try B. From Desmos and the example before, we know that this is quadratic. Also, if we were to expand this, we will see that the highest degree of the trinomial that is formed is going to be x squared, and so that's another clue for it being a quadratic. Let's look at C. Our degree here is only to the power of 1. And whenever it's to the power of 1, we call this linear. So these are the ones that we've seen last year and earlier this year. These are y is equal to mx plus b. Let's move on. Here we have a table of values, and to check to see if it's quadratic or not, we have to check our first and second differences. So let's try that. So we'll do our first difference between these two, negative 49 minus negative 46, and that'll be equal to negative 3. Let's do these two. So we have negative 52 minus negative 49, and that'll also be equal to negative 3. And let's check these ones just to finish it off. We have negative 55 minus negative 52, and that's also going to be negative 3. And so we can see that the first differences here are the same, so this makes this linear. Okay, so this D is linear. So these are our first differences. Let's try E. So let's look at E, and let's do our first differences with this chart. So we'll have 8 minus 10, which is going to be negative 2. Then let's try these two. 4 minus 8, which is going to be negative 4. And then these two, negative 2 minus 4, which is going to be negative 6. So we can see from our first differences here, we have all different numbers. So let's try our second differences. Let's try these two. So negative 4 minus negative 2. And that's going to be equal to negative 2. And let's try these two here. Negative 6 minus negative 4. And that's also going to be negative 2. And here we can see our second differences are the same. And because of that, we know that this is quadratic. We can also tell from this that it will open downwards. Okay, so the graph will open downwards. And now let's look at our last two examples, or 3 examples. So is F a quadratic? No, this one is linear. It's just a straight line. Is G a quadratic? Yes, it is. It forms a parabola. This is quadratic. And we can see with H here that it is not a quadratic. It doesn't form a parabola. So we'll just say for this one, we don't know what type of function this is, but we'll say not quadratic. And there we are. So you'll get some more practice with this, and I hope you guys use Desmos and try it all out. And I'll post all the homework online. And I'll see you guys tomorrow.